This is a continuation of being able to identify the domain and range on a graph. Just to reiterate, domain is the x values and range are all the y values. Whenever we write the domain, we're going to put them in brackets in order from least to greatest. And then if there's any numbers, you're going to repeat, and then same for the range. In brackets, in order from least to greatest, and you don't need to repeat the numbers. So in a coordinate, the numbers are going to be your x value, comma, your y value. So I went ahead and wrote down these coordinates already. So I'm going to go through, and bear with me, I'm writing with one hand and holding the camera in the other. I'm going to try to put them in order. Okay, so my domain, again, that's my first value in these coordinates. I think in order, it's going to be, don't judge my fingernails. Okay, -2, -1, 0, oh my gosh, 1, 2. Okay, and then, okay, we have a 0 twice. I missed that, but see, we have a 0 twice right there. So I didn't write 0 twice. And then our range is going to be 1. This is difficult. 1, and I think it's just 1 and 6. Yep, 1 and 6. So again, I did not write any repeating numbers. So the way I can tell if this is a function or not, it's called the vertical line test, which means if I draw, oh my goodness, okay, I'm going to try to hold this like this. I am so sorry if you're watching this. I'm trying to learn. Okay, if I draw a vertical line, okay, so that only hits once, that only hits once. Okay, so right here, I'm going to draw this vertical line. There's 2 points that hit this vertical line, so it fails the vertical line test. So that means it's not a function. So that fails the vertical line test, not a function. And what that means is that the x's repeat. So I don't know if you, like for these coordinates, they both had an x value of 0. So that's why it failed. Okay, so that's that one. So I'm going to go over to this one first. So with these types of graphs, first of all, I'm going to look at, what helps me is I look at if it's a function or not. So if you look, it doesn't look like anything hits twice. I'm not going to draw on it because it's going to make it hard to show what I'm talking about later. But I'm going to go through, okay, it looks like it's a function. So I know it is. I'm going to put yes. Okay, so looking at the domain, I know it's kind of hard to see, but there's these little arrows on the end. Whenever you see arrows, or if I'm not going to cover this one yet, but if it looks like the graph, or the lines are going off of the graph, that's an indicator that the line goes on and on and on and on forever. So, but this one, the arrow's on both ends, and so there's no stopping point. So that means that this arrow goes all the way, like the graph ends, but this line will go on forever. There's no stopping point. This will go on forever. It'll go off my paper. It'll go down the road. It'll end up, it goes off the paper. So what that means is eventually all of these y values on this axis will be covered, and all of these x values on that axis will be covered. So my domain, if all of the numbers possible can be covered, my domain will be all real numbers. And then same with y, all real numbers. That's what that says. So for those, all real numbers for both x and y. So now I'm going to go over to this one. This one, if you notice, okay, again, we do have some arrows right here. So, like I said, arrows are an indicator that it goes on and on forever. But something that's different with this graph as opposed to this one is there's a stopping point right here. So that is something that's different with this graph. So I'm going to just, look at that. But I'm going to explain the domain first. Okay, I lied. I forgot. I'm going to look at if it's a function or not. So looking at if it's a function or not, okay, if I were to do the vertical line test, even though it looks like it would fail, it really doesn't. It doesn't fail, it passes. So yes, it's a function. Okay, so now I'm looking at these arrows. If I were to continue these arrows forever and ever, I know it's kind of hard to tell, but it's kind of like a V or a U. That will continue on, and it'll just get wider and wider and wider, and it will cover everything on this horizontal x-axis. So that means all of your x values will eventually be covered because it just keeps widening, if that's a word, widening. So all of your x values known that are possible, whatever I'm trying to say, all of your domain will eventually be covered by this line if it continues on. So that's how, when it's like this, your domain will be all real numbers. But now, looking at your range, like I said, you have this stopping point right here. So that was right there. So looking at that, that means that nothing below that point can be a possible part of the range. So I'm going to look at what y value it stops at. This is a -2. So it can't, part of the range, it cannot be anything below a -2. And we know our range are y values. So for when it's like this, I'm going to put y. And like I said, it can't be anything below, so it has to be y is greater than or equal to -2. And the reason why it's this symbol is because it is allowed to include -2 because it is touching -2. So y can be -2, but it has to be bigger than -2 also, cannot be below. So y is greater than or equal to -2. Okay, so on the other hand, so that was that one, but now we have this. So it kind of looks like that, but it's turned on its side. So I know, like I mentioned earlier, this one doesn't have arrows, but we can assume it does because it's going off of the page here. So I'm going to assume there's arrows. So again, we have arrows, so that's a hint that something is I had something in the water in my head. Something is going to be all real numbers. So, I forgot again. You want to see if it's a function or not. This one, it fails the vertical line test in multiple places. So this is not a function. No. Okay. So something is going to be all real numbers. This will get wider and wider and wider. It's going to cover everything on the y-axis. So your vertical axis will be covered completely at some point. So that means our range, which our y values, will eventually all be covered. So this time our range will be the all real numbers. Okay, so then like the other one, if you look, there is a stopping point right here. And this one is on we're going to look at x. So I know it's kind of hard to see, but that is a 2. So this time we're going to do x. And if you look at where this is, it's pointing to the left. All of these values get smaller. It goes 2, and these all get negative. So it's 2 and less than, but it includes the 2. So x is less than or equal to 2. Because it can include 2, but anything smaller than 2. So what I always try to remember, and I don't know if this will help or confuse, but what I remember is, oh my gosh, okay, let me, whoop. If you get a graph like this or like this, I remember that my domain is all real numbers. Okay, all real numbers, you can write it out, or it's like this little fancy symbol, and that it is a function. And then I try to also remember If it is like a C or a backwards C, my range is all real numbers, and it's not a function. And then sometimes you might get, it might not necessarily be a C, you might get like a V, and it's the same thing, it's a stopping point. Okay, so this is another example similar to this one. It's going to be done the same way. This is not a function. You would get your coordinates and then write them domain range function. So that is pretty much graphing for right now. Sorry, this is a long video.